That's what you deserve. Okay, questions from Friday? What you got? 31? Yeah. Yeah, that's what the sub said. Nice. What is the antiderivative of 2 cosine? 2 sine, yeah. So cosine and sine ones, the only thing that's tricky about it is that you have to remember that since the derivative of cosine is negative, the antiderivative of cosine is still positive. So this is 2 sine of t. And then the antiderivative of secant squared might be intimidating, and you might think, oh, I got to use the Flower rule or whatever. But yeah, you just know that since the derivative of tangent is secant squared, the antiderivative of secant squared is tangent. Okay? All right, then they tell us, they give us an initial value. They say that if you plug in pi over 3, you will get 4 as an answer. So that means 2 times the sine of pi over 3 plus the tangent of pi over 3 plus c equals 4. Now I know that I broke down and gave you guys a circle chart that you can just look these up on, but let's just practice this. If you haven't done it for a little while, it's not that hard, especially since Elena made those posters. What is pi over 3 in degrees? 60. You go 180 divided by this. You basically replace the pi with the 180. 180 divided by 3 is 60. So that means we've got ourselves a 30, 60, 90 situation on our hands. So you know that this side is 1, this side is, and this side is 2. Okay. So to figure out the sine of pi over 3, you go sine is opposite over hypotenuse. So in this case, that would be root 3 over 2, plus the tangent of pi over 3 is opposite over adjacent, muy bien. So that would be root 3 over 1, or just plain old root 3, plus c equals quattro. Okay, so what does c equal? 4 minus 2 root 3. Because the 2's cancel here. Root 3 plus root 3 is 2 root 3. Subtract 2 root 3 from both sides and just leave it like that. Okay? So I'm going to just go back and cheat and use my technology to erase that and replace it with 4 minus 2 root 3. So I don't have to rewrite the whole thinking thing. Circle that bad boy and call it good. Okay? Yes. Nope. Other questions? Okay. Well, what'd you say? He didn't even try. That's the problem. Yeah? Just bury the hatchet? Okay. All right, this one, Maddie, we have to take 2 antiderivatives. So the first or second derivative is that. That means the first derivative would be what? Plus c. Yeah, and in this case, since we're a second derivative, we're going to have to use a little different notation for that. What would be the, oh, I forgot the x there, sorry. Minus 2x to the third, okay. Plus c1x plus c2. Because the antiderivative of whatever this number is, whether it's a 5 or a 7 or a pi or a 12 or whatever, it's just going to be put an x on there. Okay? Yeah. I don't really care. You can go C1, C2, you can go C and D, you can go S and F, you can go E and D, you can go triangle and square. Yeah, you just have to keep track of them being different numbers. I know. I knew that. That's why that ticks me off when those guys do that, because now it gets all hot. Appreciate it. All right, so when I plug in 0, I get 9, Maddie. So that right away tells you that C2 equals 9. Because if you plug in 0 for all these x's, then they all go away. So then that means that this was really x squared minus 2x cubed plus cx plus 9. And then if I plug in 2, I get 15. So 4 minus 16 plus 2c plus 9 equals 15. So c equals, what is it? 9? 6 minus 4, 2, add 16, 18, divide by 2, 9 again, huh? So final answer, x squared minus 2x cubed plus 9x plus 9. Yeah. Yeah, put it in standard form, you mean? Yeah, that's fine. That's better. Yeah. Yeah. Okay. Then you plug in the other thing to find the other c. Or is there another? Is there not another c? Oh, okay. Then you only have to do it once. So then once you find out what c equals, you just rewrite the antiderivative with that number in there instead of c, and you're done. Yeah. Yeah. Yes. Which one? The pi over 2. Okay, so the first antiderivative is 2x plus sine x plus c. So Mason, the only reason why on these we're doing the c1 and the c2 thingy is because we're starting with the second derivative. So okay. All right, and then the original function would be okay. Then if I plug in 0, I get -1. Now you have to be careful with this one because the cosine of 0 is not 0. Right, so that means this is going to be 0 minus 1 plus 0 plus c2 equals -1. So that's fun. So c2 equals 0, yeah. So that's just gone. So now I need to plug in pi over 2. Oh yeah, that's gross. So pi over 2 squared minus, I'll put that in parentheses, minus cosine of pi over 2 plus pi over 2 times c1 equals 0. Did I do that right? Maybe? Okay. Well, the good news is that the cosine of pi over 2 is 0. So this is going to be gone. So that means that pi over 2 c1 equals negative pi over 2 squared. So if you divide pi over 2 squared by pi over 2, what do you get? Yeah, but it is negative, I think. So yeah. So that means my actual retail answer is x squared minus cosine x plus, minus, hello. You can do it. Come on. You can do it. It's just the undoing. Don't be scared. Thank you. Minus pi over 2x. Okay. All right, anything else from the girls' side of the room? Sorry, I shouldn't have assumed your gender. 29. Gage, you need 21. Okay, Gage, what's the antiderivative of 6x? Plus c, right? And since this is the second derivative, I'm going to call that c1 because we're going to have to do this again. So yeah, you can simplify this to 3. Well, this one you're not solving for anything because they don't give you any initial values. So you're still just going to get an answer with c's in there, yeah. What's the antiderivative of that? Which the 3's would can't, yeah. Nice. Why did I put an x in there? Sorry, c1. And then you're just done. Yeah. Okay. Payson, you said which one? Yeah. Tegan? Oh, okay. Good idea. You have to do something. You can do C1 and C2, or you can use T and you can use a Z, but you have to have something in there. Uh-huh. Right. It's not that much harder with it. Not really, because the antiderivative of it is just always put an X on there. Uh-huh. Right. Right. Which one, Payson? Oh, okay. You're good then. 20. Okay, 23. So my first antiderivative, Shaden, I have to add 1 to the exponent. So that would make what? And then I have to divide by that plus c. Okay? So dividing by 5/3 is the same thing as multiplying by 3/5. So this would really be 6/15 x to the 5/3 plus c1. Okay? Alright, then I have to take another antiderivative because that's not quite enough yet. So what's 5/3 plus 1? 5/3 plus 1, 8/3. So this would be 6/15 x to the 8/3 divided by 8/3 plus c1x plus c2. Okay? But then I have to multiply this by the reciprocal also. So 3 times 6 is 18. And 8 times 15 is 120. We'll simplify that in a short second. 9 over 60, but then 3 goes into there. 3 over 20. Yeah, divide by 6. 3/20. Okay? Okay. Are people getting sick? No. Sir? Uh-huh. Oh, I think. Okay, what's the antiderivative of uno? No, it's the derivative. Yeah. What's the antiderivative of negative 6x? And then I'm going to throw a plus c on there. Yes. Yep. So then the answer is x minus 3 squared plus 8, which, like Elena said, if you wanted to, it would be better, really, to put it in order, in standard form. Yeah, they're all pretty easy. Okay, you're stacking what I'm chopping? Okay. Chopping is worse. Really? Okay. Why don't you come over to my house in July then, and you can chop and I'll stack. No. We bought firewood last year. I think we're good for a couple of years, especially if we don't get power out this year. What? Final answer. Negative 2x squared plus x plus 8. Yeah, right. No, we don't. We have a wood stove which we use maybe, I don't know, 3 or 4 times a year just because. But then, you know, I always want to have firewood in case it's out so we can. No, you can lose dojo points for not doing your homework. Doing your homework is a basic expectation. It's not an extra. Okay, so add 1 to the exponent. Positive 1/2, so it's going to be 3t to the 1/2 over 1/2. Oops, plus c, which is, yeah, 6t to the 1/2 plus c. Then the antiderivative of that, 3/2, you have to multiply by 2/3, so that's 12 over 3, so yeah, 4t to the 3/2 plus cx plus c. This one is a little bit different class, Gauge. In this one, I just want to draw your attention to the fact that instead of giving us 2 just regular numbers, they specifically say this is what the derivative equals. So you have to plug this into the derivative, and this is what the function equals. You know what I'm saying? Yeah, no, plug the 0 in for the x and set whatever you get equal to 8. I think you just set it backwards. Oh, right. But the way that we got that is we replaced all the x's with zeros, and then all that was left was the c, and so that equals 8. It's 60 degrees, so you go opposite over hypotenuse. What's that? Right, which is 60 degrees. Because 180 divided by 3 is 60. Bless you. So we're not quite done yet here. So I'm going to go to this one first and plug in 4. So square root of 4 is 2. 2 times 6 is 12. So 12 plus c equals 7. So c equals negative 5. Now I guess this should be our c1, right? So then, yeah. So when I write this, I'm going to go negative 5x plus c2. And then now I'm going to plug in 4 and get 20 as an answer. You know what you're like? You're like the best golfer in the group. Payson knows how this goes. If you're playing golf with like 3 other people and they're really crappy, it's really boring because you tee off, you stripe yours 250 down the middle, and then you have to wait for like 20 minutes till it's your turn to go again. Uh-huh. Right, mixes up bad and good. Yeah, yeah, yeah. Okay, anything else? Do you need help on any of these things? You're just waiting for the next thing? Okay, I think the next thing is going to be, hang on just a second, Goyles. I think the next thing is going to be a chapter 4 review. We'll talk about why in a minute. So today is Tuesday. I wasn't listening. Can you hit me with that one more time? Yeah. Hang on just a sec. One to any power is 1, yeah. Who are you talking about, Maddie? Your new boyfriend? Cross country? Oh, to, yeah, make a pizza slice? Yeah, sometimes you do that and you still are going faster. You're still speeding up. And then you get pretty terrified, yeah. And then you just wipe out because yeah. Here's my advice to you. Here's my advice to you. When you're pizza-ing, it's mostly in the knees. You really got, just bring your, yeah, don't be just like, oh, I'm putting my skis like this and it's not working. Put your knees together as close as you can. And that tilts the angle of the skis and that helps slow you down. When are you going? Because I kind of want to be there. It is super fun, yeah. Yeah, it's come to this. So the second derivative would be sine x plus c1. The first, should we go ahead and figure out what that is first, since we have this information? Okay. 0. And so c1 would equal 3. Okay. So let's change this into a 3. Then that means the first derivative is going to be negative cosine x plus 3x, because we know now, plus c. So now let's plug in the first derivative stuff into that. Negative 1 plus c equals 2. Okay, so c equals 3 again. Otra vez. And then finally, plug in 0, so that c equals 1. Okay. If you have an A now, I'm willing to call it and give you an A is what I'm saying. Yeah. Oh, I remember that from last year, yeah. No. On number one? Okay. Yep. Bam! Take the derivative and set it equal to 0. Take the derivative and set it equal to 0. I do say. No, sir. Now you sound like Payson. It's a quadratic. You don't solve it that way. The 12 thing, you look like a parentheses, huh? Yeah, I thought that when I wrote it too. But then I didn't change it because, you know. What'd you say? Okay, so those are the two possible values you get from the derivative, right? But it says, Shaden. Good God, man. The test on Thursday. Make good choices.
Is it test tomorrow?
Thursday. Today's only Tuesday. Okay, this one right here, we don't worry about. Why? It's not in between 2 and 4. So what we're going to do now is we're going to plug in x equals 2. We're going to plug in x equals 3 because of the derivative, and we're going to plug in x equals 4. And whatever the biggest answer is, that is our maximum. And whatever the smallest answer is, that's the, yep. Because we're trying to find the extreme values of the function. So you plug it into the function, yeah. Okay? So I don't know what you get when you plug in 2, 3, or 4. I'm sure you guys will figure it out. Hey, Riley. Yeah, you sure can. Yeah. That's it, huh? So you're not going to be in class today? Yeah, unfortunately. So this is a little review of your friends, the derivative rule. So I do have to rewrite the original one. It'll help if I rewrite it as 1 minus x to the 1/2. So to take the derivative, I go the first one, which is x, times the derivative of the second one, which is 1/2 1 minus x to the negative 1/2, times the derivative of the stuff inside. Excuse me, don't forget to chain rule it. So the first one times the derivative of the second one, plus the second one times the derivative of the first. Don't worry, Gage. Next week we start second half of the class, which is not derivatives. Yeah, you don't have to. What happens if you're not with us? I mean, no, probably not. I apologize. Is it this week or next week? Oh, this Friday. So I know Elma's away, and then the other game next week is away too. All right, so this is a little bit tricky one to solve. This first part is negative x over 2 times root 1 minus x plus square root of 1 minus x. How do you feel about that, Elena? The 2 goes on the bottom because it's on the bottom of the fraction. And the negative 1/2 moves this piece to the bottom of the fraction also. Okay? And then this and the negative 1 stay on top to make the negative x. Okay? Alright, then I'm going to set that equal to 0 again. So then I'm going to, since I could really move either one of these to the other side, but since this has a negative here, I'm going to move that over there because it's going to be a little bit easier. How do you feel about that? And then I'm going to pretend that this is a fraction and cross multiply. Yep, exactly. So cross multiplying this way is simple. That's just x. Cross multiplying this way isn't actually that bad because the two square roots cancel each other out. So yep, exactly what Maddie said, 2 parentheses 1 minus x. So distribute 2 minus 2x, add 2x, 3x equals 2. So x equals 2/3. So this number right here is in the interval. So our possible choices are the two endpoints of the interval and the critical point that we got from taking the derivative and setting it equal to 0. Just like okay, hang on just a second. Just like we did with the last one, take those three numbers, plug them into the original function. The biggest answer you get is the absolute maximum. The lowest is the absolute minimum. Yeah.
Worst case scenario is we can't take a derivative because we don't know how, so just plug in those numbers into the intervals and have a shot at getting
I
the
guess I see what you're saying because, yeah.
I don't want to be parallel
Right.
the same number. Yeah.
Right.
He's an 8. I'm an 8 too.
I'm a 7. I'm a 7. What are you guys talking about?
Yes, I can draw your X's and you can draw your X's.
How else could you draw your x's?
Well, I do it this way and you do it that way.
Wait, wait, wait.
You do
I do it this way.
the first one instead.
You go this way.